I'm Stephen Foskett, and this is Cloud Field Day in San Jose, California. We're here with Cisco Systems and a panel of bloggers, podcasters, writers, and speakers. We invited them here to interact and discuss during the presentation and also to represent the wider IT audience. If you'd like to see more videos like this, you can look at youtube.com/techfieldday, or you can go to techfieldday.com and learn how to become a presenter or a delegate yourself.
So my name is David Cheperdak. I'm Senior Architect in the Cloud Services Office of the CTO. And today I'm going to be talking to you about some of the services and technologies we're building around containers and microservices. Kind of to start this discussion, we must first think about, well, what are some of the underlying building blocks or foundations that we want to deploy containers on? So if we were to consider some of our core Cisco building blocks, really culminates to compute, storage, and networking, right? With some additional orchestrators and controllers in there as well. So what I'll first draw here is for compute and storage, we have UCS. Of course, we have APIC ACI. And we also have some additional appliances, right? We have like SourceFire, we have some underlying security appliances, IPS, IDS, etc. So we also have some appliances. I'll just go app for short. However, that is some of the Cisco hardware building blocks, but it's by no means actually the foundation or the complete foundation. We also have some the component of orchestration and controllers. Orchestration and controllers are really the driving or the abstraction layer on top of underlying hardware and infrastructure, of course. We want to abstract how we consume UCS. Maybe that's UCSC, maybe that's a higher level controller that provisions infrastructure like UCSD, for example. And what I haven't touched on here is there's also a lot of our partners and customers consume public cloud, as was mentioned before, right? We have GCE, EC2 instances, etc. So I'm just going to put public cloud over here as well. Pub cloud. Now that's great. We have a model of orchestration and controllers. We have underlying platform and infrastructure, and we have public cloud. What this kind of looks like is the possibility for a hybrid cloud model. We have, a metapod here actually is, and really what this culminates to is how do we consume this, right? And so I'm just going to draw a box here which kind of will denote how we consume underlying Cisco infrastructure. And that would be really a metapod play. If you want that private cloud instance and also consume public cloud, that's also available too. And then we also have something that I'm going to call Metal as a Service. There's no reason why that I couldn't deploy a container or a service directly on the compute chassis or on APIC ACI. In fact, there are some great plugins and additions we're making to Docker and some of the other contributions to plug into APIC ACI's network model. So I can get the high performance of a container and the policy and governance of that network. That's great. This actually makes a fairly rock solid platform and infrastructure that we can build interesting applications and services on top of. However, ultimately, what is it? So if we double click onto what is in this layer, I will focus on one area and one technology that we've been working on. And that technology is called Mantl.io. Go there, it's down, it's fully open source. All open source components. We are doing massive contributions across the set of open source suites that comprise this technology stack. And what we're seeing actually is, and when we talk to our customers and partners, is everyone is building a container stack to a reasonable degree. And actually, interestingly enough, many of those components are the same. I've talked to 5 different people. I was actually at HashiConf, right? And we had a booth there, and we're demoing everything that we're doing, and customers come by and say, hey, I have a little bit of Mesos, a little bit of Kubernetes, and we're doing this. It sounds like you guys have most of what I have already, but you're doing more. Can I replace what you're doing with what I'm doing with your technology stack? And why would someone want to do that? One reason why they would want to do that is because, well, it's an open source community, right? It's basically OpenStack. It allows you to make your extensions, build your unique plugins to interface with your technology, and really leverage kind of the support of the community to build a common unified stack. If we were to double click on this, I don't know where my eraser is, but I hope this will suffice. What I kind of will start this conversation with a question. And that question is, what is better, Kubernetes or Mesos? Anybody?
That's not who you're talking to.
Sorry, what was the
Every
question?
developer.
What is better, Kubernetes or Mesos?
Depends. Yeah, I mean.
Exactly.
Yeah.
There is no silver bullet. Or if we were to just say we need both, just for some use cases, say we have a use case which is, well, I want to run a big data app and a hyperscale web app. And I want the application to consume data from the hyperscale web app and also the big data app. I'm just going to draw two big boxes here. One box will be Mesos. The other box will be Kubernetes. That's great. Now we have two independent clusters of Mesos and Kubernetes. You can now deploy apps across them. Both have an API. However, I would say I want to deploy an app here and an app here. How do these apps talk to each other? Right? Okay, Kubernetes uses etcd as a service registry, right? It also uses it as kind of a metadata metric. It uses SkyDNS or another DNS provider to provide some basic A record support. Mesos has some of its own service discovery mechanisms. What we've done is we've actually used Consul. Consul is three things. Consul is a key value store. It's a DNS server. And it also provides a basic clustering mechanisms for service discovery and health checking. So what we can actually do is we can actually install or integrate Consul into Mesos and Consul into Kubernetes. And actually, this is a contribution we've made back to the Kubernetes community, is we've actually said we can take out etcd and replace it with Consul, which you can use that as a key value store, which also provides your DNS support as an option. Now, what's interesting is Consul provides clustering, not just clustering between these two stacks running on the same cloud or the same instances, but actually across data centers. And you can actually do cross data center key value record lookup. So if I'm in one data center, I can look up the registered metadata from a service running in another data center. That is useful for running multi-data center clustering of container stacks. So these are now clustered. And we've written some tooling and automation that's all open source that will say when I deploy my, say in Mesos, a big data app, say a Spark-based application, when we deploy Spark, it is bound to a particular volume on a host. And when that restarts, we can rebound the volume. So when our Spark application starts, we actually see that that gets registered in Consul. Well, we have metadata, right? Some basic properties about that container, its exposed ports, its URI, its endpoints, and things like that. Maybe it's health checks, right? Say this is an API that you can query for a health check. And also an A record. That A record could be my app.service.consul. Now, what's interesting about this is that is a pre-deployment tag that I can add, right? And I can say any service running in this cloud is a peer to this service, and they're going to peer, or client-server model, they're going to connect on this A record domain name. What it allows is this is a late binding, which allows us when we register the A record, this service can now query and obtain the correct IP address of the remote host. And similarly,
excuse me, let me ask you a question real quick.
Sure.
Who's doing this? So typically the people that I've talked to, they have chosen Mesos, they have chosen Kubernetes, they've chosen Swarm, they've chosen a platform to
Sure.
use.
Right.
And I get it for mobility, but who have you, why are you guys even doing this?
Good question. So let's step back. I'm describing to you a use case.
Yeah.
And that use case is not a use case for everybody.
Sure.
I can draw a line right down the middle, and you can use this half if you want. So you're not limited to running both. You can run both stacks. You can run one stack. I can run Kubernetes. I can run Mesos. It's your choice. And all the tooling and functionality that we've built into the stack, all the operational complexity. Mesos by itself doesn't give you much, right? DCOS adds some additional components, but that has its own, proprietary elements. You also have Kubernetes. Kubernetes doesn't give you much. How do you do load balancing? How do you operationalize these platforms? And that's something that we're trying to support in open source, is that when you get the Mantl stack, you get all of all the tools and technology you need to operate and manage it yourself. Whether or not you use more than one or more stacks, it's up to you. So I can add all the operational support packages just with Mesos if I want to, or just with Kubernetes. In this, I'm just showing a use case of highlighting some of the unique capabilities we've added.
Yeah, I'd love to hear just like, after this maybe just one or the other, what the other use cases are. That's something that maybe we'd probably see more.
I actually have a demo of a use case for you, and that will highlight how we're using and deploying this stuff. This is kind of more this is even the foundation, and in some ways I like to think of as, hardware is a pool of hardware, CPU, memory, and disk, and we can add a controller on top of that. We have cloud, which is a pool of resources. And when we talk about container stacks, it really is another pool of resources, right? What's interesting is what happens above that stack. So then I can bind an A record into console, and now these two services can talk to each other and discover each other. But what's missing is we don't have any networking, right? How do they securely communicate in a tenant way? What we've done is, under the hood, there's lots of different technologies that we're working with. There's Contiv. And what Contiv provides is this underlying mapping between policy enforcement, similar to group-based policy, but simplified, API, so that when I create a container, it can bind to a network, and that will instantly have a policy attached to it. Create a network, create a policy, create a container, map the container to the network, and that policy is now transient with that particular container. And likewise, I can do the same thing over here. When I bind that particular service to that, now they're on the same tenant and the same network. Contiv also patches into APIC ACI. So now not only do we also have a bridge mapping from a container workload directly into the underlying network fabric. And we have a mapping between higher level container policy directly into lower level network fabric policy. Our Contiv is not the only one. We also have Calico. And of course, we have Flannel and a bunch of other open source technologies. We've actually open sourced VPP. If you may not know what that is actually our packet acceleration stack in all of our switches and routers for high performance offloading. That is now the FDIO project. And we're actually working with Calico to integrate that packet acceleration into Calico's networking technology. So what you get is a whole bunch of underlying, you can do overlays, you can do network fabric integration, a wide variety. You really have a choice of what meets your existing data center, whether on Metal, on cloud, or vice versa. So now that we also need monitoring, so we've added some monitoring components, right? cAdvisor, and we have some other metrics and analytics that we built in. It's going to speed up a little bit. We also have a standard Kafka message bus and a few other things, and we can funnel all the metrics from your containers or services directly into Kafka, and we can feed that up and expose them as an open API that you can pull from. So you can do intelligent things with. Likewise, you also have APIs exposed from all of these. And now you have service discovery, you have underlying networking, and you have metrics and monitoring, all built into a common northbound open API. And what that gives you is, I want to add what we call, standard container lifecycle management. Where I want to apply policy, I want to do security, I want to define connectivity, I want to do alerting of those events. You can build your own controllers or systems, and then we can do closed loop orchestration, or we can deploy across multiple stacks. Any questions or thoughts?
A lot of people are saying on the Twitter stream they'd love to see a demo.
All right, well, let's do a demo. Those things are not light. So, Mantl. There you go. There you go. Thank you. No. But what we see here, I apologize, it's a little bit awkward to see the screen. But you can see here that we've integrated. Where's my mouse actually? Let's see where my mouse is. Not that side. Here it is. It's reversed. So here we can see Mesos. We have Marathon, which is the scheduler of. It's okay. Yeah. Okay. Thank you. We have the.
I don't know how hard it is to stand there. Try to do that.
Yeah. We also have Kubernetes, and we have Consul, and we use Traefik, which will be replaced by Nginx. Nginx is a load balancer, but what's interesting is when you have Kubernetes and you have Mesos, they use different load balancing. So we can unify that so you get the same VIP, the same reverse proxy for all of your applications and services. If I were to double click on the cluster, I can zoom in, say, well, hey, here's all my slaves. Right, it's not a big cluster, but it gives you basic memory and utilization. We can see we're running a framework, right, which is actually our Consul framework. And we can see other aspects of the cluster, like a whole bunch of running applications and services. These are all containers. In fact, all of these containers, a part of our deployment process is we have a bunch of Docker services that we ourselves deploy inside of our own cluster, a part of the creation of the cluster. If you want like security or monitoring, after the cluster is bootstrapped, we can deploy those monitoring services on every slave, for example. Similarly, we can like double click on Marathon. Double click and say, hey, look, we have Marathon running, which have all our apps that are running, and we can get all the metrics and monitoring of all these different services out. We can also double click on Consul, which is actually doing some health checking for us. It's giving us some warnings. Let's see what we see here. So here I can see all the nodes, right? I can see all my Mantl nodes belonging to my cluster. I can double click on the control node. I can see all the services that are running, and I can see all the health checks. Right? All of it's freely exposed for me to consume. We're just making it neat for you. Here we can actually see there's a warning. Let's see what the warning is. Looks like it's not a warning. Check the file. No, I don't know. It could just be hey, this log doesn't look right. The key value store, we can apply ACL, and we can just like a lot of data plugged into this. And of course, every new framework that we integrate, whether it's Docker Swarm or it's OpenShift or any new paths or container stack we want to, it'll just appear as another tile that you can double click on. Everything is exposed. But this is just an overview of the platform, the container stack. What can you do on top of it that's interesting? Well, what we can do on top of it that's interesting is really what we've been building is called Shipped. And what Shipped allows me to do is basically the full lifecycle management, creation and deployment and construction of container images. From creation time all the way to deployment time, 5 minutes or less. Right? And that accelerates and allows our partners and customers an easier way to consume microservices and say, well, how do I build a microservice app? How do I integrate it? How do I deploy it? So I can simply go, hey, I'm going to create your applications. I'm going to create let me make it a little bit bigger for everybody. A little bit too big. I can go, hey, I'm going to create a new application. Right? I'm going to call it Cloud Field Day. Go. I'm going to create an app. There we go. Now I can choose what kind of app do I want to build. Right? What kind of language do I want to build from? And I can just pick a language. Let's just choose Golang because I like Golang. I can just say I'm going to create a new registry called, say, test2. This will actually go and create all of my development environment for me. All my Git repos, all my code, give me example code already committed. I've already added in my GitHub information, so it's all pulled from GitHub.
So what's doing that on the back end?
On the back end, it's creating a repo, and if I pull up GitHub in my account, you'll see a new repo created.
Right, what's creating it? Which service?
So Shipped is creating it. So maybe I didn't highlight that.
So you had to set up your GitHub stuff.
Yes, I already had to do that. So Cisco Ship.io. You go to Cisco Ship.io. You can log in with your GitHub credentials, and you can begin creating apps. And we have a demo cluster available for you that you can just deploy your apps. And we have public. We have people creating thousands, if not millions, of apps. And we actually had to clean it out because we're running out of space on our cluster.
So outside of the fact that you're doing this is container orchestration and networking, how is this different from Clicker?
Okay. So in fact, we're working on integrating those two technologies together.
Okay.
We do. Let me double click here a little bit for you and show you something different. Let me save the project, and we'll change to another app. Right. So what you can see here is we're actually doing a live build. Let me just change my app, actually. We'll change it back to my app. Right, and here my app has gone through a full CI/CD process for containers, and we use multiple pluggable backends to doing container CI/CD build and deploy. And you can define your own test cases and customize. We also can deploy, so we can create new environments. Right, and I can say, deploy this particular environment to Mesos, in this case, or Kubernetes, or any other container target that you want. Cancel. And then once you've done that, you can run it. And so when you run it, well, we actually see that I'm running one container, right? It's on Mesos. It's a staging cluster. And we can also see a live policy and metric stream. And we can actually modify the policy for this particular diagram. And we can control the thresholding and alerting. Do I want storage or resource contention for any given part of my application? And all of the monitoring I was talking about earlier on the whiteboard flows up into the system. We consume it. And then we analyze it across a policy that you can define. And you can see this little yellow line down here. This little yellow line is actually my resources that I've defined as a constraint, which how many containers I can run. And I can go into a lot more detail here, but it allows you to not only build and deploy, but we can also graph like things like the network utilization. And all of this is all pulled from open source components under the hood, right? And how does this consume? How you orchestrate traditional applications. Yeah. Well, we actually find that there's a balance. So everything you see through good programming, everything through the UI is accessible through the API. The entire cluster stack is accessible through the API. So if you want to build your own shipped equivalent, you can. If you want to integrate that container stack cluster into your own CI/CD, you can. Shipped is a way. Some of our customers have actually said, I don't really want the CI/CD. I like the application intent part, whereas you help me manage and deploy my applications across multiple container stack environments.